In this video, I'm going to derive the formula for the reduction for the integral assigned to the nx. The formula is negative sine raised to the negative 1 of x, cosine of x, when I need to copy down, all over n plus n minus 1 over n times the integral assigned to the n minus 2 power of x dx. So this is a theorem. Now, not all of these reduction theorems are proved by or integration by parts, but this one is. Okay, so here's the proof. So we have the integral of sine n of x dx, and I'm going to break off for sine x. This is equal to the integral of sine n minus 1x times the sine I broke off dx. And then we make some substitution. We are going to do this by parts. Not the integral, but I call one part u and the rest dv. So u is the sine of n minus 1 of x. So then du will be, now just remember that this is really sine of x all to the n minus 1. So we use the general power rule. We bring down the power, we make the new power 1 less, then we multiply by the derivative of what's inside, which is cosine x dx. And what we get is, let me just write it down again. It's n minus 1 sine raised to the n minus 2 power, I'll put it there, times cosine of x dx. Okay, that's du. dv, well, we're told, or we decided that that was sine x dx. So v will not be cosine x, because the derivative of v, the differential of v, should be dv. The differential of cosine x is negative sine x dx. That is, we need to put a minus sign there. Now, I'm going to call the original integral I. So I is equal to u times v, which has a minus sign. So it's negative sine n minus 1 of x times cosine. That's uv. Minus the integral of v, which has a minus, so this becomes plus cosine x du, which is that mess. N minus 2 sine of n minus 2 times another cosine x right there dx. So one of the things I'll do is, well, I'll do two things. Cosine x. One is I'll bring the constant out in front of the integral, and I'll write this next. And for cosine squared x, I'll write 1 minus sine squared x dx. And this is equal to negative the sine raised to the n minus 1 of x times the cosine of x plus this n minus 2 times the integral. Now I'm going to distribute. I get this times 1 times dx, which is sine raised to the n minus 2x dx, and then minus the integral of sine n of x. That looks familiar. That's I. And I do have one little typo. Well, okay, I don't have a typo. Remember, we have the n minus 2 in front. So this is negative the sine of raised to the n minus 1x times cosine of x. And now I'll distribute. You get n minus 2 times the first integral, x dx, minus n minus 2 times the second integral. But that second integral is just I. Remember? Okay. So I have I is equal to this. I is equal to negative the sine of n minus 1 cosine of x plus n minus 2 times some integral dx. And I have another multiple of I, except as it says right here, I'm supposed to be subtracting. So when I bring it to the other side, the left side I have I, and when I bring this over, I'll be adding n minus 2 i's. So here I have 1 I, and then you're going to add n minus 2 i's. You're going to have n minus 1 i's. This is n minus 1 i's. That is, when I bring this term to the other side, I'll have n minus 1 i's. Okay, so on the left side, I have n minus 1 i's, and it equals to all of that. Negative the sine raised to the n minus 1 of x times cosine of x plus another integral. But also sine to a power. But the power has been reduced. And I don't want to know what I don't want to know what n minus 1 times I equals. I want to know what I equals, which means all I have to do is divide both sides by n minus 1. And there's your reduction formula. I, remember, I was nothing more than the integral of sine to the nth power of x dx. And it equals this. This is no more integrals. And the new integral has a sine power 2 less. So what you need to do here is redo this whole nonsense over again. That is, keep using this formula. You know, if you have sine 6 of x, you'll get this stuff plus some constant, but then you'll have sine 4th of x. So what you do is you hold on to this, because you have to figure out what this is, and then you have sine 4th of x dx. Well, that equals this stuff with a different n plus this constant times the integral of 2 less sine squared x dx. Okay, now this one you should know how to do. So you do it, and you take all of this and you plug it in right there. Okay, so you may have to use this reduction formula a number of times. This completes the proof of the integral, or the reduction formula for the integral of sine raised to the nth power dx. See you in the next video.